All right, folks. You're doing okay? Doing okay? All right. So I think all of y'all are 101 except for a couple, right? Just the two of y'all 201. All right. So most those are 201. I talked to you. Most of the stuff we're doing, but we'll cover for y'all as well. But so these were the question distribution we sent out. I can go through old exams as you have questions, and we'll go over those. But first, just sort of recap what all you'll see on the test. You're going to see estimates, right? So I'll give you some object that is either right in front of you or something that you're very, very familiar with, and I'll ask you to say what is the area, what is the length, what is the volume of that. You need to know what is a meter, what is a centimeter, your pinky, maybe what is a millimeter. A millimeter is a tenth of a centimeter. So you might have to do some unit conversion. You saw some of this on the old tests if you've worked through those, but be able to determine what is the volume or the area of that object. Okay. Um, then you'll have some trig. I'll show you a triangle. I'll say what is the angle, what is the side. We're okay on that, right? On the trig stuff? Yeah, I can work through some. We'll look at some, but you'll have two questions. What is the side? What is the angle? Those are the two questions. Hopefully those are gimme questions. And then dimensional analysis, you'll have two questions. One, I'll give you some equations, right? And I'll ask you, are these dimensionally correct or not? And then I'll give you another equation, and I'll ask you, what are the units of this variable? We saw one of these where I say like x over t is equal to b times blah blah blah, and I ask you for the units of b. Remember seeing a question like that in the quizzes? Yeah, so you'll see something like that. Sig figs, I'll give you some expression, ask you what is the answer with the appropriate number of sig figs. I'll ask you some question about standard of measurement, just one. What is the standard of measurement for blah? All right, just know your standard of measurement. Units, conversion of units, you have to convert units. One of those will be a powers. Probably one of them will be from like a metric system to a British system or vice versa. I'll give you the unit conversions for the British system. You don't need to know how many meters in a mile, but you probably know that anyway, right? Is this what? 1609, right. Kinematics, you'll have several kinematics, 6 total. Some calculations, word problems where I describe the motion of an object, and you have to calculate various things about it. One of those is going to be a free fall problem where either you're dropping something or you're throwing something up in the air and you have to find something about it like the height that it goes or the time that it's in the air. We can work through one of those, but you'll have one of those. It's very important for 201 too. You'll have one like that as well, where it'll be very important for the next chapter when we get into 2D motion. Graphs, you'll have to do qualitative analysis of a graph, looking at a graph and telling me something about the motion. A position versus time graph, remember the slope gives the velocity, velocity versus time, the slope gives the acceleration, and the area gives the distance. 201 too, you'll have to do that. So you have to do qualitative stuff. Then you also have to do quantitative stuff where I give you a graph and you find the slope of the graph or you find the area under the curve. Make sure you're very clear on what the graph is that you're looking at. Is it v versus t or x versus t? Because the slope and the area tell you different things in those cases. And then only for 101, you'll have 2 problems with vectors, one of which will be finding the x or y component of a vector. The other of which will be finding the sum of 2 vectors, one of which is on axis, one of which is off axis. So it's at an angle from the x-axis, and then finding either the magnitude of the sum and the or the direction of the new vector. And then also 2 conceptual problems for the vectors. You'll have one where it's like an arrow, 2 arrows, and I ask you what is the sum, what is the difference of those 2 vectors. We can work through one of those. And then a second one, which will be about the components of vectors. We work through a series of problems in the online or in the quizzes, the participation quizzes, where you, if your x component is negative and your y component is positive, what quadrant does that put you in? And then what is the appropriate angle for this, or what happens if you change the x or y components of a vector? Sort of a question probing that knowledge about the x and y components of a vector and how changing them affect the vector. That's the test. That's it. That's it. Where do you want to start? How about dimensional analysis? Feel okay with it? You want to start with that? That works? Okay. All right, so I'll pull up some old tests. Actually, let's just, I'll show you an example here. So with the dimensional analysis, like let's say that I have 1 over v squared, or let's say I have a over v squared times t. And I want to know what are the units of that. In this, I'll just write out the units of each one. So I have meters per second squared is a, t is seconds, and then v squared is meter squared over second squared, but I flip it to second squared over meter squared. And then I cancel some stuff out. That cancels, one of these cancels with that, and I'm left with just seconds over meters. All right, so you need to know how to do that. And then let's say that this is actually part of a bigger equation where I have some variable, we'll call it b, and uh, it looks like that. And I want to know what are the units of b. Well, now you'll also need to find the units of this at over x. That's meters per second squared, seconds, 1 over meters. That cancels. One of these cancels with this. And so I'm just left with 1 over seconds. So I want to figure out some variable b that will cause this equation to be dimensionally correct. And the units of that are going to be, I'm going to need a second squared up here to give me a seconds over here, and I'm going to need a meters over here. So the units of b would be second squared over meter. If that confuses you, you can also just solve it for b. I have seconds over meters. I have to multiply this side times seconds to get rid of that, so it gets rid of that, and I'm left with seconds squared over meter. That's also the answer. Yeah, so see what I did? I just solved for b, sort of, but dealing with the units. You'll follow me? You'll have one of those. You'll also have a series of equations where I show you some equations, and you have to figure out, are these dimensionally correct or not? So let's say x over t, a v over x. Are these equations, is this equation dimensionally correct? And you do it the same way. Meters over seconds, meters per second squared, meters per second, 1 over meters. Doesn't look like it's going to be. Those would cancel. Oh, no, it's not. It's like meters per second cubed on the right-hand side. So that is not dimensionally correct. But you'll have several that you'll need to go through. So make sure that you're quick on it. I think that some of you know how to do it. You're just a little bit slow. You need to be pretty fast on those because those are meant to be pretty straightforward and easy. Okay, practice will help. There's lots of problems to practice on, so practice, practice, practice. Okay, what else? What other topic? Let me pull up those topics again. Kaylee? Okay, the graph qualitative. Okay, you'll see, what did I say, 3 of those. Yeah, people have trouble with this. It's just sort of a different way of thinking. So let's consider that I have a position versus time graph that looks like this. And I want to know, how does this translate into a velocity versus time graph? Right, I have this position versus time graph, and I want to know, what does the velocity versus time graph for this object look like? And I'll give you a series of velocity versus time graphs, and you'll have to pick them out. You've seen questions like this, right? Don't try to memorize them because there's so many variations. It's easier just to memorize or know how to do it. The velocity is given by the slope of this graph. The velocity of x versus t is the slope. So I look at how the slope changes, and that tells me what this graph is going to look like. Remember, I'm looking at the slope of the tangent line. So here I have a big positive slope. That's a really steep line. And then as it goes on, it gets smaller and smaller, but it's always positive. So I start out with a big positive slope, big positive, and it gets smaller until it goes to 0. So I'm going to have a line that goes in that direction. So my v versus t here would look like this. Now what if I had a different line? Say it looked like this. That starts out with a positive or negative velocity. positive, right? Because it has a positive slope. But in this case, it's not big, it's really small. It's basically 0 here. And then it gets big in the positive direction. And so my function there is going to look like that. Now, what if I have a function that looks like, is that too confusing, drawing them all on top of one another like that? It is too confusing. Let me just erase it then. Can I erase them? They were different colors. Listen, for Christmas, my wife got my children and I one of those flare pins, like with 12 different colors. But we just got one and we had to pick them all out. So we only got like 3 or 4 pins each. Because we only get like 50 bucks to spend on one another at Christmas, and it doesn't go very far, so you have to sort of be creative. But anyway, so we all got to pick out pins so that we could do stuff like this, like write everything in different colors. It was really cool, actually. All right, so what if I had a graph or like this? Is that initially positive or negative? It's negative. Is it big or small? It's big, right? So um, I'm going to start out negative and big, and then I get closer to 0. Remember, the negative represents a sign, not a value. So whenever I talk about the negative, that means it's in the negative direction. Okay? Right, because this is the origin, and below here is negative numbers. So if I start negative and big, like that one, it looks like that. I can put one additional line on top of it, right? Is that okay? All right, so let's see, another one would look like that. Now that one starts out negative 2, but is it big or small? It's small and it gets bigger, so it's going to look like that. Could also give you some scenarios and ask you to draw what the velocity versus time graph looks like, or to pick it out of a lineup. So for example, dropping a ball, if I take a ball and I drop it down to the ground, the velocity versus time graph for this, it's going to start out small and negative and go like that. If I also include the bounce, like some of y'all did in lab, unfortunately the Friday students won't get this, but if it goes down and then bounces back up again, it's going to look like that, right? This is just the dropping part. This is the bouncing back up again. We saw this on the concept test. There were a series of questions about this. Also, if I just throw it up in the air, if I throw a ball up in the air, it goes up and comes back down again. The velocity versus time graph for this will look like that. Initially, it has a positive velocity that is decreasing till it gets to the top, reaches 0, then it turns around and comes back down again. All right, you'll have, what did I say, 3 questions like that, Madison? Maddie. You go by Maddie, right? Right, so you could see a question like that as well. So for this one, let's just look at, say, the red line, for example. Here, I know that this thing has a negative velocity and it's speeding up. If an object is speeding up, its acceleration is going to be in the same direction as the velocity. This red line has a negative velocity, so its acceleration is negative. Right, because it's speeding up, so the velocity and the acceleration are in the same direction. Whether they're positive or they're negative, they have to be in the same direction. But look, we know that because this has a negative slope, right? Likewise, this one is slowing down in the negative direction, so its acceleration is opposite the velocity, or positive. But look, we know that because this line has a positive slope. So they're all sort of linked together. Is that clear? Oh yeah, if you can draw the velocity graph, you'll be able to know it because it's whatever the slope of that line is. Uh, Megan, you have a question? No, okay. Candace, no. Shoot. Abby, I'm sorry. Well, that was the bounce, right? That was the, if you look at the position versus time graph, it was y versus t. It looks like this. It sort of looks like a bounce. Yeah, this graph corresponds to this graph, right? Because I have a small negative velocity. It gets bigger and bigger. That's tracking along here. And then I have a big positive velocity that gets smaller and smaller. Big positive velocity that gets smaller and smaller. Looking at the slope here. The students have a lot of trouble with this. Yeah. Okay. You want to look at some kinematics calculations? All right. First of all, let me just tell you, you shall have a problem where something goes up and comes back down. Same for 201, folks. All right, so if I have an object that goes up and comes back down again, I need you to be able to tell me the maximum height and also the time required to get up to the top and the time required to come down again. So just remember there are a couple of facts here. If I know V naught, let's say, I don't know, it's 10 meters per second or whatever. I also know that the velocity at the top is equal to 0 because it stops up there. Remember, the graph looks like this, right? For my velocity versus time for this motion. So at the top, the velocity is 0. And I also know that it takes an equal amount of time to go up as it does to come down. That those two times are equal. So I can use all those facts to come about and figure out both the height that it goes up and the time. So first I like to write my equations. V equals V naught plus AT. And again, you can probably just write these on the form that you'll get with the test so you have them right in front of you. Then I can sort of get rid of some things. Here I know that this value is equal to 0. So I can say 0 is equal to 10. That's my V naught here. Minus 10 times t. I'm going to call this t top to remind me that that's just half the time. That's the time required to get it to the top. And so if I solve that, subtract 10 from both sides, divide by negative 10 on both sides, I find that t top is equal to 1 second. Listen, I'll give you really easy numbers, so hopefully you won't even need your calculator except for those trig functions. If you want to use it, that's fine. But anyway, so it takes 1 second to get up, and then if I want to find the height that it goes, I just plug in that 1 second. I say y equals 10 meters per second times t, which is 1 second, plus 1/2 negative 10 times t, which is 1 squared. And that's 10 minus 5. So this is 5 meters. That's the maximum height. It's just important for you to know if when we get into 2D motion, you'll need to know how to go through this procedure. Kaylee? Okay, anytime you're in free fall, it's going to be negative 10. But sometimes, like we're talking about things moving in a horizontal direction, car, I don't know, whatever. Right. Yeah, so if you have something moving in a horizontal direction, it can either be positive or negative. It doesn't have to be 10. It can be 2, 3, 12. I don't care. Okay, so whenever it's in free fall, yeah, and you'll have a at least one free fall problem. I think just one. Um, okay. Now you can find other things, just sort of a quick little side, like for 201, like y'all have a more complicated problem. It's not a lot more complicated, but you can find the velocity at any one particular point, right? You just put in the time. So like if I want to know at 0.5 seconds, what is the velocity? I can just put in that 0.5 here. I can find the total time, which in this case would be 1 second. Okay. Yeah, Megan. Oh, so if I want to know the velocity at 0.5 seconds, I would just say V is equal to V naught plus AT. That would be 10 meters per second minus 10 meters per second squared. That's the acceleration times 0.5. That's 10 minus minus 5. That's 5 meters per second. So that's the velocity at t equal 0.5 seconds. Maddie? No, I won't tell you that. No. You'll need to read the problem. Like often the v naught isn't really explicitly stated, especially or sometimes v is 0 and sometimes v naught is 0. So like if I have something I say it's initially at rest, that tells you that your v naught is equal to 0. But if I'm talking about the context of a problem where you have an object that's slowing down, then the v naught isn't 0, but the v is 0. Okay, so a lot of that's just reading the problem and saying, oh, well, this thing is slowing down, so my initial velocity is blah, 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 and my final velocity is this and that, and I don't know the time required to stop. I do know the acceleration, all that. Okay, does that answer your question, Maddie? Abby? For this particular problem, mm-hmm. For the problem that you will have tomorrow, yes. Okay, okay. Let's look at just some other kinematics problems on the old exams. Let's just go back a little bit. Y'all are okay with all the unit conversions and stuff? Okay, this one's pretty straightforward, but let's just look at it anyway. A speeding car is traveling 40 meters per second and pulled over by a state trooper. It decelerates at that rate. What distance does the car travel before it stops? Well, it's not a trivial problem because we actually don't have the time. We have a couple of different unknowns. So let's see. Let's just write down everything that we know. V, is that V or V naught? V naught, right. So V naught is equal to 40 because that's my initial condition. And I know that he's pulled over and then he decelerates and I want to know the distance. So his final velocity is going to equal 0. Uh, I know that my acceleration is 2 meters per second squared. But you have to be careful here because it's not 2, it's what? -2. Did we? I think we worked this one in the in-class section. All right, so A is -2. Um, I don't know what T is, and I don't know what the distance is. So I need to solve for the distance. So this is a two-step problem. I have V equals V naught plus AT. Notice I have some unknowns here. I don't know what T is. And then my other equation is X equals V naught T plus 1/2 AT squared. By the way, I don't know if it's confused you, but I don't know if you noticed that I sort of interchange X and Y. If y'all notice that? They're both displacement. Y just corresponds to vertical displacement, and X is horizontal. That's not terribly important now, but next chapter it will be when we get into projectile motion. Okay, so here I have two unknowns. I have T and X. So you first have to solve this one for T. That's 0 minus 40 over -2, so -40 over -2. So it takes him 20 seconds to pull over. That's a long 20 seconds when you got a state trooper behind you, Sydney. Oh yeah, sure. So right here, let's see. I want to solve for t, so I subtract v naught from both sides. This is what you mean, right? Yeah, subtract v naught from both sides, so that gives me v minus v naught equals to at, because these terms go away, and then I divide both sides by a. That gives me my function for t. Or if it makes you feel better, you can put numbers in and just sort of do the numbers step by step. Okay? All right. Now, here, now that I know t is 20 seconds, I can just solve for x. So v naught is 40, t is 20, plus 1/2, a is -2, times 20 squared. That's 800 minus 400. 400 meters. It took him a quarter mile to stop. But 400 meters would be the answer. Notice here that if you don't get this right here, like if you put a positive here, you would put 1200. And I forget what these are sort of different variations of wrong answers. Remember what I told y'all, right? Just because you get an answer doesn't mean it's what? Right. So make sure you check your work, but don't spend too much time checking your work because you got 28 questions to answer, and it's a little bit crunched, but I found that 27, 28, that's sort of the sweet spot for number of questions. Okay. All right. Go over what now? A trig problem. Yeah, I thought you said a trick problem. There are no trick problems. A system of two equations? No. No, you will not have that. Right. No. So that's like a system of two equations where I have two unknowns in each equation, the same two unknowns. No, in the one-on-one class you won't. Emily, Sydney, y'all will, of course. That's just all right. Okay? Yeah. All right. Yeah, no, don't worry about that. Let's see, I don't see one on here, but I'm just going to do one on the fly. So if I have, I'll give you a picture of a triangle, all right? I'll tell you this is angle theta, or I might give you the angle theta, and I give you two sides, let's say 4 and 6, or whatever, and I ask you what is theta and what is the hypotenuse. All right, define the hypotenuse, or some variation of this. I would give you 3 pieces of information, or no, I'd only give you 2 pieces of information. All right, I would just give you that, and then I could ask, oh no, I have to give you 3. I have to give you 3. Because you can't find theta with just 4, right? So I give you two pieces of information. Yes, right. So I could find h is just the square root of 4 squared plus 6 squared. 16 and 36. What's that? 42, 52. So approximately 7. And then you would need to find theta. It's the inverse tan, remember SOHCAHTOA, opposite over adjacent, 6 over 4. You know your triangles. That comes up again with the vector problems. So, but you'll have a couple of problems, one finding a side, one finding an angle. That'll be just easy peasy trig problems. I can give you a picture. Okay, Kaylee? Okay. Well, this is very related, but you'll have something like that too, where I give you, say, I give you a vector, and I say that it's, I don't know, 4 meters at 30 degrees, and I ask you what is the x component, for example. And the x component here, right, the x component is just this side of the triangle, right? And so the x component would be 4 cosine 30. All right. Sydney, Emily, you guys won't have vectors, but you do have you have a couple of trig problems on there. So hopefully those will be pretty easy. So anyway, remember this comes about because my cosine of 30, see, so ca is adjacent over hypotenuse, so that's my x component divided by 4. And so my x component, if I cross multiply, is 4 cosine 30. And similarly, your y component would be 4 sine 30. Does that answer your question? Okay. Okay. Any other particular areas? Uh-huh. Yeah, so as you'll also have one where I'll give you a couple of vectors, and I'll ask you to find either the direction or the magnitude of the sum of those two vectors. Hours? Oh, the spelunker? Yeah. There's a homework problem like that. Listen, yours will be slightly simpler. I'll give you one where I say that you have a vector. Say a guy travels, I don't know, 10 meters in the positive x direction and 20 meters at, at 30 degrees above the plus x-axis. And I ask you what is the magnitude and the direction of his displacement. So I like to draw the vectors first. 10 meters in the plus x direction looks like that. It's on the x-axis. 20 meters at 30 degrees above the x-axis looks like that, where this angle is 30 degrees. And so our resultant vector will look like this. Right? And I want to know what is the length of this vector, and then also what is this angle. I'll call it theta. You will have one like that. That's very similar to the Spelunker problem, except on that one you just had a third vector. But it works out exactly the same way. I'm gonna helps me too. I'm gonna show you right now. What, Mackenzie? Huh? Right. Okay. I can work through that one. Can we work through? This is the same type. It is. It's very, very similar. It's just a little bit simpler because it has one fewer vectors. With cardinal directions. You're not going to have cardinal directions. I can show you quickly, but on this test, you will not have cardinal directions. In upcoming tests, you shall, but I decided not to put them on there right now. Okay, well, let's go ahead and do this one, okay? So here, I just put my x components and my y components. I like to do a little table like Kristen said. Uh, on the first vector, I have 10 meters and 0 meters because there is no y component. And here I have 20 cosine 30 and 20 sine of 30. Now I know these are both positive because I've drawn the vector, but if that second vector was like this, for example, then the x component would be positive and the y component would be negative. I always find it very helpful to draw out my vectors like this, and then you can check your answer and make sure it's on the up and up. Just take a big deep breath and just draw out your vectors. Take that extra 20 seconds to draw them. You can't take a big deep breath? Okay. I add them up. Uh, Unfortunately not, but a lot of those questions are from old exams, so you can look back at old exams. All right. Yeah. If you sort of shuffle back through the old exams, most likely some of them are not on those old exams because they came from finals, but uh, but most of them are something very very similar is on the old exam. Oh, those are the x and the y components of that second vector. So if I break down this, well, let's look at this red vector up here. I'm going to break it into its x component and its y component. This x component is 20 cosine 30. This y component is 20 sine of 30. Just remind you where that comes from. The cosine of 30 is adjacent, that's the x component, divided by the hypotenuse, that's 20. This side is 20. So the x component then is equal to 20 cosine 30. And then you can make a similar argument. The sine of 30 is the y component over the hypotenuse. So opposite over hypotenuse. So the sine of this angle is this length divided by the hypotenuse. So that's where these expressions for the x and the y components come from the definitions of cosine and sine. That's why it's so important for you to know your trig functions. We're going to use those a lot in chapters 3 and 4, so it's good that you get them now for 201 as well. Does that answer your question? Yeah, Ashley? Okay, I'll answer. Let me finish this right quick because we still need to find the magnitude. So this is 17, and then this is 10. If I add up these, and so what that tells me is that my new vector, I'm going to do it up here, has an x component equal to 17 and a y component equal to 10. Yeah, I did round off. I really should have. This really should have been 20, right? Is that what you're thinking? Oh, did I? Let's see, 10 and 20 times cosine of 30. Oh yeah, that's 7. I'm sorry. Yeah, this should be 27. I'm sorry. Yeah, I didn't add the 10. So 27. Were you the one that wrote me about the sig figs? Yeah. So there will be an explicit sig fig problem. For the other problems, I'm not saying sig figs aren't important, but the sig figs are in the answers. Like I'll give you proper sig figs in the answers, so you don't really need to sweat that too much. Now, if you keep your significant figures a little bit differently, you might get an answer that's off by like, a decimal place or maybe 1 unit or something. But you'll be able to pick out the right answer. So I don't want you to sweat sig figs that much on the test, except for that one problem where you have to give the explicit answer. Yeah, I don't want you to do that. All right, so now if we want to know the magnitude of this, I just say the square root of 27 squared plus 10 squared, and that's equal to whatever it is. And if I want to know theta, I do the inverse tan of 10 over 27. And that is whatever it is. It's a pretty small angle. It's about 20 degrees or so. Okay? Now, Ashley, okay. Well, that's part of the problem is knowing how to draw it. So read off the vectors to me. Oh, okay. 10 units. So she has 1. You could see something like this, but 10 units at 30 degrees above the negative x-axis. So our first vector is 10 units long at 30 degrees in that direction, and the second vector is, and the other one is 10 units like this. You could draw it on the x-axis if you want, but I like to draw them tip to tail. That way I can draw my resultant vector like that. Remember, you can translate vectors wherever the heck you want, okay? That's fine, but I always like to draw mine tip to tail, just like you would do when you're adding them graphically. That way you can draw your vector, and I know that this vector is going to be, it's going to have some angle less than 30 degrees just from drawing it. I know that it has a length that's obviously more than 10. All right? And you do it the same way as you did this problem, except that when you do this, your x components are both going to be negative for those vectors, and your y components will both be positive or 0. Okay? All right, what else? We don't have a whole lot of time, so what else? You want to, Mackenzie? The magnitude is always the hypotenuse, like in this case, of the resultant vector. So it's the hypotenuse of this triangle, the blue triangle. Right. Yeah, so when you're doing the x and y components of all the vectors that are given, You're doing that to find out the sides of that right triangle, because you add them up to get the sides, the x and y components of that right triangle. And Abby, I think, had a question, and Kristen. Oh yeah, yeah. And Kristen, what was your question? Okay, well think about it, and let's address Abby's problem. So I have position versus time, looks like that, positive or negative acceleration. It has a negative velocity. I'm talking here. Wait, negative, it has a negative velocity that's doing what? Speeding up or slowing down? Speeding up, so the acceleration is negative, right. If it's speeding up, the acceleration is always the same direction as the velocity, okay? Okay, let's do one more, okay, or one or two more. How about this one? Negative or positive acceleration? Now think, okay, this the slope here is negative, so it has a negative velocity that's slowing down, so it's positive. This one has a positive acceleration. No, it depends if it's speeding up or slowing down. Was this one negative? It was, yeah. All right, if it's speeding up, the acceleration is the same direction as the velocity. If it's slowing down, the acceleration is the opposite direction of the velocity. All right, hold on. Let me see what Kristen, did you remember your question? No, you have to do something different. Let's address that because that's a big part of your test, okay? And Kaylee, was yours related to this? Wh- Okay, what was it about? Okay, let's come back to that. Let's address Kristen's problem because that's um, like a graph problem like this. Yeah. Okay, so like this graph. Let's get a different one. I think we've worked this one. And okay, so like this one, for example, you'll have a couple of problems where I give you a graph and I ask you to do quantitative things to it. So this one asks for the average velocity. You'd do this the same way if it was asking for average acceleration, except the graph would be a v versus t, not a x versus t. All right, so if I'm looking for the average velocity from t equal 2 to 7 seconds, right here, 2 to 7, that means that I'm really looking for the slope of the line that goes from there to there. Or I can think of it as in just terms of the definition of average velocity, which is delta x over delta t. That's x final, which is -4, over the change in time 2 to 7, which is 5, -4 meters over 5 seconds. That's -0.8 meters per second. So if you see average, just think, I'm just pulling the data points off. I want to take the difference in the position, in this case, or velocity if you're looking for acceleration, and then dividing by the total time. Now, if you're looking for instantaneous acceleration, that's a little bit different. Let's find a different graph. No, so like for, I'm sorry, repeat that question. You said, right, except you just have a different graph. Sure, you're right. So let's say that, Maddie, what's your question? Is it about this? Okay, go ahead. Oh, shoot. I didn't want to do that. Oh, I can't undo it. Why was the top -4? Oh, it should have been -5, shouldn't it? Is that what you're thinking? All right, well, that's t equals 7, and I was doing 2. Yeah, right there. Did I do that wrong? I'm sorry. So velocity average is delta x over delta t. That's -5 minus 10. Oh, that was all wrong, wasn't it? Yeah, I'm sorry. And then the time was 7 minus 2. This is meters, this is seconds. That's -15 over 5, which is -3. I don't know where I got that. I'm sorry. Right. Listen, after about 10 a.m., I'm pretty worthless. Like, I just really don't want to talk to me after 10 a.m. Okay? Okay, now back to Kristen, your question. If I'm doing instantaneous instead, let's say I want to know the instantaneous at 3 seconds. The instantaneous velocity at 3 seconds. Notice I wouldn't give you a range of time. In fact, I think that was the next question. No, it was a little bit different. So if I want to know the instantaneous velocity at this point, I would just find the slope of this line. I would draw a triangle, do my rise. My rise goes from 5 to 10, so it's -5 because it's dropping. My run is 2 seconds, and so the instantaneous velocity is -5 over 2, or -2.5 meters per second. Okay, but you could also have, and 201 folks, you're going to have to do this too, where I give you a graph and you have to find these things, where you could have a function like this, where it's x versus t, and then you have to draw, say at this point, a tangent line and find the slope of that tangent line. Now there will be some judgment when you draw that tangent line as to draw the right tangent line, but the answer will be, sort of hidden there, a bunch of really wrong answers. So it'll be clear what the answer is if you get it close. Right, so if I was looking for instantaneous acceleration, it would just be v instead of x. Megan? Right. If I was looking for instantaneous velocity, anytime you see instantaneous, think slope. I'm looking for the slope. Dong, dong, dong. And if you're looking for average, think data points. I'm pulling off the data, the actual numbers, and calculating it. You're still finding the slope of a line for the average, but it's not a tangent line. It's a line that connects 2 points. All right, Caitlin? This is the vector question, right? Can you say it? Okay, y'all can see something like that. Like that fits into that whole x component. It had a magnitude of 25. Is that right? 25 meters. That's the magnitude of the vector. I'll call it r. And rx was what? 12. And it just asked what is theta? All right, what is the angle? And I know that the x component is equal to the magnitude times cosine of theta. And I just solved that for theta. So that's going to be the inverse cosine of 12. You're not a moron. 12 over 25, 61 degrees. All right. But you will need to do it. You need to know how to find x and y components, because if you don't get it on this exam, you're going to be hurting in the next chapter and the fourth chapter for sure. Okay? Y'all can do that. Easy test. It's an easy test. No cardinal directions. No cardinal directions. It'll be all from the x or y axes. Abby? Look, if you go onto the, yeah, look, if you go onto the old test site, up at the top it says question distribution. It tells you which chapters are covered. Ooh, but you know what? So like exam 3 here, for example, in 2013, numbers 1 through 6 were from chapter 3. But you have to be careful because we're only covering part of Chapter 3, so just look for those vector questions. You know what types of questions we're doing for Chapter 3, so. Right. I would look at those old tests. A lot of those quiz questions come from the old tests. Most of them do, in fact. That's all, y'all?